Hello everyone, Earth.Otherwise here to continue our journey through game programming in C++ start to finish by Eric Yuzwa. Our game logo requires three things: a starfield background, some black letterboxing, and a company logo. I've gone for the choice of making a custom logo for this game, meaning most of our code is going to be in the game itself and not the engine. In fact, all of it is. We're going to put the starscape in the background, draw the letterboxing over top using that same starfield background but made black, and then we'll fade in our company logo over top. The only even mildly difficult thing in this list of requirements is the fading, something I added myself. I'm not going to show you how to get a hold of the pictures, as I'm sure you're capable of that, especially since I'm just going to make mine in Paint. What I will show you is how the code of the game logo is going to turn out. But before we actually code the game logo, we'll need a new function in our multi-sprite. Because you see, right now we don't have the ability to change a sprite after we've created it. And we'll need to change the alpha value on our game logo if we want a fade-in effect. So here in multisprite.h, we are going to add a new void function, which is going to go right in our multisprite, right at the bottom, or right here underneath add sprite. It will be void set sprite alpha, and it is going to take a int for the sprite and a GLU byte for new alpha. Now just put that in the .cpp file, create a definition for it, and we can do the quick work of it. So our setSpriteAlpha function is going to go into the color of each vertex in the sprite. So if we go msprites, and then we go into sprite, then we're going to go dot m bottom left dot m color dot ma is equal to new alpha. And we're just going to do that for each of the 4 vertices. And that is what that looks like. And while we're here, if you haven't already done it, we are going to comment out all of the code pertaining to our query since we no longer need it. So just comment out that first bit, and then comment out begin query, then comment out this bit while we wait for the query, and don't need any of that. And we do not need to get an integer at the end there. Oh, too much backspacing. And I believe that is all we need to do there. So back in our game logo, it's mostly going to be copy-pasted the stuff we're going to be doing from our main menu, where we're currently doing most of the rendering. Later we might want to add to our engine some kind of standard rendering class, but last time we made the logo state class, but I've now realized that that class makes no sense in our current context. So we're just going to take the init functions and the private variables and give them to the game logo class. We can create a generic logo state class later if we feel the need. So we're going to pop into logo state, copy actually all this, just Control C that, pop into game logo, and Control V it there, turn this protected into private. And we're going to need to make sure that we have multi-sprite and simple shader in our GameLogo.h. We are not inheriting from logo state anymore. And all of this should be otherwise, or your engine name, which I shouldn't have to remind you should not be the exact same name as my engine. So that is that for that bit, if you can believe it. And in here are init. Copy that and paste it here. Except it's not logo state, it's GameLogo. So there's our init. We are actually going to be adding to it because our GameLogo is going to have a couple of other things in it. And to get those things, we need to include ImageLoad.h, and we need to include math.h. You will see why in a minute. Along with that, we'll need a couple of other functions. The first function that we need, I have named logo update render loop. Just to be super freaking explicit about it, and it is a void function. Don't forget that. And the next function, also a void function, is simply render, as that will handle our basic rendering stuff. In our private variables, we'll need a glint for the perspective. So glint mPerspective ID. Maybe I should say perspective uniform ID, just to make it extra clear that we are that is going into the shaders. And we will need a GLM mat4 for our orthographic matrix. Orthographic matrix. Or, just ortho or ortho matrix. Any way you want to squeeze it. So, we've inserted the initialization of these things into init, or we're about to anyways. So I completely forget how to initialize these, but we do so in the main game. So we'll just copy that from there. So see this perspective matrix. Just going to go ahead and Control C that and Control V that into our init function. Except instead of shader perspective ID, it is perspective uniform ID. And instead of program ID, I believe it's M program ID. Yeah, just M program ID. M program ID. And then we have to do the matrix. So the matrix is defined not long after we do the camera. Here we are. Don't need that GLM mat4 business. Copy that. Paste it here. And remember to copy and replace. And then this, instead of camera 2D, is M camera. Which I do not believe we have initialized yet in this instance. Because we have a camera 2D, but no, I don't think we've initialized it yet. We will have to do that before we get our ortho matrix. Right here should be fine. mCamera dot init. And then we'll probably have the camera's initialization passed into this init function along with everything else. So a camera, wrong. This camera requires, I completely forget. 2 ints, a GLM-vec2, and a float. If I'm not mistaken, though it could be a bunch of floats. We can actually look at it if, yeah, 2 ints, a GLM-vec2, and a float. So int screen width, int screen height, GLM-vec2, camera position, and float camera zoom. And then we'll simply pass this into our init. First is screen width, then screen height, then camera position, and then camera zoom. There we are. And then it should be ready to give up the ghost. And by that I mean pass the parameters on to our ortho matrix, not die, as that is what it actually means. But if I cared about what things actually meant, I probably wouldn't be in programming. Now we move on to the rest of the CPP file, which we need to give definitions for these two. I like using IntelliSense on Visual Studio to do so, just because it saves me from having to type it up. Now, here it is. So we're actually going to work from bottom up. So render is going to be copied wholesale from the main function here. If we just scroll down to where we actually do our rendering, we are going to need to copy clearing the buffers, using a program, getting the orthographic matrix. We don't need any of these. We need a render batches, and then we need using program 0. So we will just copy all of that and pop it into our GameLogo. GameLogo. Paste all that there. Get rid of all of this unnecessary fluff. Get rid of this fluff. And then separate things which are not directly connected to each other. So none of this is really connected to each other. So there we are. Now, need to just change the names. And program ID, this is actually that, perspective. Ortho is actually orthographic matrix. Multisprite 2 is actually M multisprite. And we do not have a second program. And there we go. But there is one other thing we have to add to this little render function, and that is our swapping of the buffers in the window. In order to do that, we need a window pointer. And I'm not sure if we have window yet. We do not. Number include, I believe it's simply window.h. Could be wrong about that. Doesn't appear to be. Now we want other, not other, otherwise window? Yeah, otherwise window pointer. That's important. M window. And then in here, whenever we render, we want M window to point to swap buffer. That way we'll actually be able to see what we are doing. Okay, next up we go into our logo update render loop, the main meat of our stuff. So the depth buffer, if you'll remember, we enabled the depth buffer in order to do, what do you call it, three-dimensional stuff. Essentially, the depth buffer asks if the pixel that it is about to draw is closer to or further from the camera. If it's closer to the camera, it overwrites the current pixel that's there. If it is farther away, it does not. In this way, even if we're drawing things out of order, things will still appear to be properly ordered. This way, we don't have to go through the arduous task of ordering everything from furthest away to closest every single time we render. However, this seems to interfere with our orthographic projection here, in that things just don't work correctly, because I think there's like no depth at all in 2D, I think according to OpenGL or something. Anyways, we're gonna completely get around that by going GL disable GL underscore depth. I think it has to be all caps. Depth underscore test. And then at the end of it, we're going to GL enable GL underscore depth underscore test. That way we simply don't have to worry about that problem at all. So, what are we actually going to do in this render loop? First, we're going to load our starscape into a GL uint. I'm going to call this starscape texture ID is equal to, and then I'm just going to pop over to main because I don't remember the actual function call, scroll up to where we make something. Do we even make things anymore in here? Apparently not. But we need essentially a multi-sprite, like an add. Yeah, here we are. Add multi-sprite. So in here, just copy this. This is our load image call. And we pop that into here, and we just paste it right here. Boop. Except instead of Apple, it's Starscape. Simple enough. Then, after that, we are going to go back and copy this whole thing and paste it 4 times in our GameLogo. Once for the actual Starscape, if it will, there we go. Once for the each of the black bars, that's going to be our letterboxing, and once for our logo. And these load PNG things are going to be replaced with Starscape texture ID. Just going to replace all 3 of them with that. These second and third sprites are going to need to be tinted black. So that's 0, 0, 0, 255 for each of these 4 vertices for both of these sprites. And that is what that looks like. These multi-sprites, so it's actually going to be M multi-sprite for all 4 of them. And I just remembered, because it's in the script at this point and not earlier, that we are going to be storing this screen width and screen height in our member variables. So I'll just pretend that they exist. Screen width is equal to screen width. That's completely not how you spell it. And then screen height is equal to screen height. Because down here we are going to create a a float, which is quarter screen height is equal to screen height divided by 4.0f. Now if we just pop into here, go ahead and might as well make them floats since that's how they're going to be used. Screen width, screen height. So we did that because our first starscape here is going to be going from 0, 0 in the bottom left corner up to screen width and screen height. So it's going to be going from 0, 0 to screen width, screen height, obviously. And these little banners, the first one is going to go from 0, 0 up to screen width, screen width, up to quarter screen height. This is so that we get the bottom letterbox, which will only cover the bottom quarter of the screen. And then this will actually go not from 0, 0, but from screen... Oh, wait. That's wrong. 0x, yes, but not y. Y will go from screen width height minus quarter screen height up to screen height, if you get what I'm saying. So that will be the top quarter of the screen that will cover. And then our logo, since I want it centered in that, will go from the left. Since I want it to be a box whose height is the screen height, it means that the top, it's going to be a box that's half the size of the screen in the center of the screen. So instead of going from 0, 0, it's going to go from 1/4 screen height for the Y and 1/4 screen height for the X, I believe. And then it's going to go up to 1/4 minus screen height in the Y and 1/4 minus screen height in the X. Let me just show you what that looks like. Just a little interjection. I'm going to take this and actually make it another variable called float 3/4 screen height is equal to that. Just so that I'm not continuously running this calculation. Run it once and then use it everywhere else. And this is what I was just talking about looks like. The starscape goes from 0, 0 to screen width, screen height. The bottom letterboxing goes from 0, 0 to screen width, quarter screen height. The top letterboxing does not go from 0, 0. It should go from... I got this backwards. It should go from 3/4 screen height. Oh, it does. It goes from 0 3/4 screen height. I'm dumb. To screen width screen height. And then our logo goes from 1/4 screen height, 1/4 screen height to 3/4 screen height, 3/4 screen height. If that makes sense to you, it will when you see it, if it doesn't already. Now we prepare our batches. Prepare batches. And we move on to the actual loop part of our update render loop. Right before the loop, we will need 4 integers. The first int is our start time, which it will be set by SDL_getTicks, which will return us the number of milliseconds since the application started on any system. Though I'm not sure if I included the correct include in order to use that. I believe we have to include SDL.h, but we should have that through Multisprite. Oh well, I can just include it here at the top. Number include SDL/SDL.h. There we are. And SDL.ticks plural. There we are. So, as I said, milliseconds since the application started on Windows, Mac, and Linux, I think. Don't quote me on that because I'm not entirely sure. Next is our current time, which is currently set to start time, because we just started and we do not want that to be empty when we do our checks against it. After that, we have our logo length, which is the number of milliseconds we want our logo to run for. I'm picking 5,000, which is 5 seconds. Finally, we want our logo time, which is equal to the current time minus the start time, as that is how long the logo has lasted so far. Now we go into a while loop. While. So, while our logo time is less than logo length, this loop will continue. Our fade in will be inside an if-else function. I'll just stick the else in there, as that is important. Scroll down a little so we can see it more clearly in the center here. Up, and we'd bottom off that curly bracket. Now, as I was saying, we are going to work from the bottom up again. We'll start in the else function, where we will do multisprite dot set sprite alpha. This is going to be sprite number 3. It's actually the 4th, but we start at 0 if you'll remember, and we're setting it to 255. This is so that if for some reason our sprite is not set to maximum opacity by the time we get around to the end, our logo will be set to maximum opacity. Then we need to go multisprite dot prepare batches, because if we do not do so, the effects will not take. And then we want to call render, so that we render our stuff. Now, up in the if side of our if-else statement, we want to say so long as logo time is less than 4,000. So long as 4 seconds have not passed, it will call this. But once 4 seconds have passed, but the last second, our logo will be opaque, guaranteed. I'd like to note here that this approach of changing a sprite and then preparing batches is incredibly inefficient. In fact, it would probably be easier in the future to set things up so that we can give all of the fading information to a sprite and then let the sprite itself take care of fading in and out. But for now, this is the easiest and quickest to implement solution. In the if part, as I was saying, so long as our logo time is less than 4,000. So 3 lines will be a copy-paste, pretty much straight from here. In fact, right from there. Except this time, we're going to replace this with a mathematical equation. It is going to be pow, which is a power function given to us by math. And inside 2 brackets, we're going to go logo time divided by 251, all of that to the power of 2.0f. Now we're going to close that bracket. Close that. So essentially this says that we'll take the logo time and divide it by 251. I got 251 because that's like, I forget what it is, but it's like the square root of 4,000 divided by 255. So it's like, I think it was like, I forget what it is, but it's the number that we need. So this will give us a integer or perhaps a float, and then that float to the power of 2 will give us a nice smooth upwards curve from 0 alpha to max alpha. I tried using a linear equation, which would have been far easier and less processor consuming, but I found that the logo faded in far too quickly. It didn't look like a proper fade. Essentially, it looked like it went from no opacity to all opacity in about 1 second. Because apparently, like 1/4 opacity looks pretty much the same as full opacity. Anyways, moving on. Now at the bottom of the loop, outside of our if-else function, we are going to set the current time equal to SDL_getTicks. That way our current time is up to date. And then we will set our logo time equal to the current time minus the start time. So then we will have how long it has been since this loop started running. Now we go into our main function. We're done here in GameLogo. At least I think we are. We probably made a mistake and we'll probably have to come back. We're going to include GameLogo .h. And right after we've created our window, we can go ahead and run our GameLogo. GameLogo.init. And then we're going to pass the things to our init that we need to pass. Make sure it's spelled correctly. So, our vertex shader, which we haven't created yet, is going to be in... we don't actually have a folder for our shaders yet. We should create a shaders folder, but it is going to be called logo.vert and then logo.frag. Then screen width is currently 512. We should create a variable for that, or even better, have it read in from our .ini file. glm vec2 0.0f 0.0f, and then camera zoom is 1.0f. And need a closing bracket there, and there we have that. Now we just need to call game loop dot logo, not loop, dot logo update render loop. And that will run our entire logo. And then when the logo is done running, we will go into our main game process. So I believe that's everything we need to do in our main function. Now we need to create our shaders for our logo. This is due to the fact that our old 2D texture shaders are now our 3D texture shaders. So what we're going to do is we're going to create a copy of our texture frag and texture vert shaders. You actually do this in the folder, not in the not in here in Visual Studio, since it won't let you. Anyways, you copy these, you rename the logo, you you input them using add existing items, and then we will edit them from there. So here we are in our newly created logo.vert file. First, we are going to remove everything we don't need. And all we need in the vertex shader is the perspective, UV, and color. So pretty much all of these disappear. Don't need any of those. Don't need any of those. We will keep our locations, our layouts, just because if we don't have one of these, our multi-sprite in its current form might not be able to, send stuff to us. And all of this below this color here, we don't need. And there we are. We are very quickly back to our original vertex shader. Now into our fragment shader, where we need to get rid of everything again. And all we kept was the color and UV. And the only uniform we kept is the light position. And down here, if you will remember, all of this is brand new, and we should get rid of the .rpg there, rbg there, and get rid of this, and replace it with this texture call. Paste that down here, get rid of everything above it. And there we are, back to our simple input the texture, output the color format. One final thing to note. What we're doing here by multiplying the texture and color comes with a steep limitation. If for some reason the texture you're working with has 0 for red, green, blue, or alpha, you will never be able to tint that color. For example, if you have a straight blue color, then the texture's value for red and green are 0. It doesn't matter what tint color you use, you will only be able to affect the blue of that texture and not add any green or red, since 0 multiplied by anything is still 0. Same goes for areas with 0 alpha. You will never be able to have them be opaque with the current system, which is just an important thing to note. Later we may wish to make the distinction between alpha, color tint, and color shading. But with all that done, we can run the application and see our janky, bad frame rate logo appear. So we Control-Shift-S, we build Earth.Otherwise, and then tutorial, or whatever you're calling your game these days. I always click rebuild because sometimes when you click build, I think if it's already built, it doesn't do it. But yeah, anyways, after this, we run it and we see what happens. Seems here we did something in our main that got rid of program ID. I think we must have... Oh, oops, I Control-X'd instead of Control-C'd our program ID. So we can fix that very quickly with a quick little Control-C, Control-V, And then just change this a tiny bit to program ID, and this to texture, and then this to texture. But I saw another error there that might be more pertinent. Term does not evaluate to a function taking 0 arguments. Line 79. This is not a function. Put some brackets there that didn't belong there. Anyways, now let's build, and it looks like there was a parse error. There is a curly bracket where it shouldn't be in our fragment shader. Where, oh where is that curly bracket? It's not the curly bracket, it's the lack of a semicolon. Oh well, that's still better than, anything else we could have gotten. Looks like we got a straight up game crash, well, application crash. Looks like a couple of variables are not available for render. That's very strange. I'm not sure why we're throwing an error right here. Value is not available. Usually I just Google search these, but I'm going to compare to the other thing that is working correctly. Figured out the error, had to go into debug mode to do it. But you see here where this error is occurring. It's occurring here at swap window. So we call swap buffer there at the bottom of render. But if you'll remember, I mentioned that we need a pointer to window here in GameLogo, GameLogo.h. We need this here pointer. However, this pointer is I never actually give this pointer here in the init function. So we need to do that. Window pointer, window pointer. And just copy that into the .cpp file up here. And then set it window is equal to window pointer. And then in the main, we also set it and new window. There we are. That should be the end of errors. Let's see what it says. Looks like we got one of our homegrown errors, vertex file. So when we were compiling the vertex file, something stopped us from compiling it. Don't know what, but something stopped us. We have the uniforms, we have that. It's called logo.vert. What could possibly have stopped us? Where do we compile it? Should be right here. Compile link simple shaders into program ID. And the shaders we hand them in the main is logo.vert and logo.frag. They should be compiling fine. I'm gonna see if I can sort this out. Here we say that if the vertex file does not open, then we output that error, meaning our vertex file simply didn't open. It is called capital logo.vert. Let me just double check that we sent that. logo.vert, and it does exist in the folder. That is very strange. I looked at it, and it isn't this that isn't compiling, it's these, because these are not titled properly. This is actually texture vert.vert and texture frag.frag. Completely forgot about that complete ballsing of the spelling. But that does mean that this goes by without me even seeing it, which is very strange. Let me just double check everything. Okay, everybody. I found the single line of code that we forgot. We need to initialize our multi-sprite. I also changed something. I added cameras.h here because I got rid of logo state.h. Anyways, let's go ahead and run this baby. There's our starscape. There's our logo fading in. It's hard to see the black bars because they're black. And they would be black because they're just copies of the starscape anyways. But yes. Oh, and there are our cubes. So, we have the logo all up and running. This has been Earth.Otherwise. That little mistake took me longer than I needed to in order for me to find it, and thank you for watching.